Hello, everyone. My name is Tomer Amiel, and I am a current FEU grad student studying computer science. And today I'm going to talk to you about natural language processing using Spacey. And later on, I'm also going to show a demo to show how to apply Spacey for simple NLP tasks. So first, what is Spacey? So Spacey is a open source is a free open source Python library that helps with executing many NLP tasks. It is used for building information retrieval systems, natural language understanding systems, and to pre-process text for deep learning. It also supports over 49 languages. It supports tokenization for over 49 languages, which means not only English-speaking countries can use this, it can be used worldwide. It also has built-in NLP models that can be used for many NLP tasks. And these NLP models actually show how Spacey is more of an object-oriented approach, because these models usually use objects, and also their functions returns objects usually. Now I'm going to talk about the most common features that exist within Spacey. So for pre-processing text, we have tokenization, sentence segmentation, lemmatization, and stop words. For linguistic features, we have part of speech tags, we have dependency, we have parsing, and we have named entity recognition. And we also have pre-trained word vectors and predefined NLP models that exist within the Spacey library. Now I'm going to show some of these features and show how they may be used using Spacey. So I'm going to move on to a notebook. So as you can see, we're in a notebook. And the first thing I did was install Spacey. After I did a pip install for Spacey, I imported all the Spacey libraries that I would need, and imported, also set some other arrays that I will use for later on that I will show. I first of all picked a document actually that we used for our third homework. I believe this is a positive movie review. And this is the text I will use for to show the pre-processing text. And so I first of all, I printed out the text to make sure that I set the text equal to the variable and it works fine. And after that, I created our Spacey object. So I loaded in a Spacey object into this variable called NLP. And afterwards, I set x equal to this object that has all this text that I took from the document. And this object, this NLP object, basically now has all this text that we can now apply all the Spacey functions. So the first feature I chose to show is tokenization. As we can see, it's very simple. Basically, it says that for each token that's a text, for a token inside of X, you want to set that equal to tokens. And after printing, it shows that it prints out all the words inside the document as a token. So if you look here, our first word is every now and then. So we have every now and then it keeps on going with every word. So it tokenized every word. Now we're going to move on to sentence tokenization, which is very similar for word tokenization. As we can see, the only difference is that we set each sentence for a sentence inside of the sentences inside of our NLP object. We set that equal to a variable, and this variable will now hold all the sentences that exist within the document, but separately, as we can see. So we have our first sentence, then we have our second sentence, and it goes on and on like this for a whole document. So now this is sentence tokenization. As we can see, it's very easy to apply. Now I'm going to move on to stop words. So first, removing stop words. So this follows the same logic as before, but now we have an additional thing. So for each token that's a text, for a token inside of X, we add also that if the token is also a stop word, so if it's false, we know that it's not a stop word, because if the token is a stop word, it'll have to be equal true, which now here you'll have all the stop words, and here you'll have all the tokens that aren't stop words. So for removing stop words, you said equal to false, and for extracting all the stop words, you said equal to true. As you can see here, we have all the stop words, and, to, s. These are things that don't really will be good for, let's say, a summary. So you'll need to take all these words out. Next is extracting entities. So to extract all the entities with Spatie, it's also fairly simple. As we can see, we set this variable equal to all the entities inside of X, and then we also give them a label. So as you can see, we have a Matthew Broderick, and it's a person, as you can see. So we have the entity with the entity type, and this does this for each of the entities inside of the document. Reese Witherspoon is also a person, as you can see. So this is fairly simple as well for extracting entities. For part of speech, same thing goes for part of speech. We print out the token text and also the token part of speech for each token inside of X, which X again is our Spatie object. So it again gives you the token with its part of speech. So as you see, movie is a noun, comes is a verb, and so on and so on. It prints you each token and it's part of speech. So this is part of speech tagging. Now to move on to lemmatization, we print out each token text and each lemmatization for that token, for each token inside of X. So as we can see here, we have gets and get. So these are, so this is inside of this is the token, and this is its lemmatization. And same thing with caught and catch. So it kind of gives you a word that's similar to the token. Now, this is the most lengthy part of my demo, which is text summarization. I'll be using an extractive text summarization method using frequency. So at first, we set a word frequency array, and this is going to get populated with all the words and their frequencies. So as we can see here, we have this word movie, and it appears 2 times in the document. And it does this for each token and each word and so on and so on. So it checks that, first of all, the word is not a stop word. It checks if the word is not a punctuation, and then it checks that if the word is not already added to our word frequency. Because if it is added, you just need to add another one to the amount of words that already exist. So after having this word frequency array, we need to check each sentence score. So to do that, we basically add up all the frequencies of each sentence. So if the word, let's say, will have a high frequency, the sentence score will be higher than a sentence that has words with lower frequencies. And now after that, we get each sentence and its score. So now we have each sentence score. And after we have each sentence score, we can later on use the n largest function that basically returns a list with the n largest elements from the data set. that can be defined by iterable key. And our key is the sentence score. So each sentence score that has the highest score would get returned, and then finally added into our summary. And if we print out the summary, we can see that this is shorter than the document, like before. And these sentences that exist within these summaries have the highest score. So this will give us a good extractive summary. And again, extractive summary is a summary that summarizes a piece of text using sentences within the piece of text. So yeah, so this ends up giving us an extractive text summary. And yes, this is the end of the demo part. Now I'm going to talk about some conclusions from me experiencing with Spacey. So the conclusions that I got are that Spacey is fast and excellent for extractive text summarization. As we saw, it was fairly simple to apply the Spacey's functions in order to summarize the piece of text that we had. It was very easy to use and it was user-friendly. And it also came in with the NLP objects that we used in order to score each word and each sentence using that tokenization that we did. But yeah, this is the end of my demo. Thank you so much for listening, and I hope you have a great day.